Imagine you're on a game show. Three big doors stand in front of you. Behind one is a brand new shiny car, and behind the other two are goats. You pick one door, let's say door A, maybe because it's red or because it just feels lucky. The host, who knows exactly where the car is, gives you a grin, then walks to another door, door C, and opens it to reveal a goat. He turns back to you and asks, "Do you want to stick with your original choice or switch to the other unopened door?" That's the famous Monty Hall problem. It sounds simple, but it's one of those puzzles that messes with your brain. Almost everyone's first instinct is, well, now there are two doors left, so it's 50-50. It feels fair. Two options, one prize. So why would switching make a difference? But the truth is, switching gives you a much better chance of winning. And here's why. When you first picked your door, you had a 1 in 3 chance of choosing the car. That means there was a 2 in 3 chance the car was behind one of the other two doors. That part is easy to accept. Now the host steps in. He knows exactly where the car is, and he always opens one of the remaining doors to reveal a goat. He never opens the car by accident. That small action, showing you a goat, is the trick that changes everything. Your original pick doesn't magically become more likely just because a goat appeared somewhere else. That 1 in 3 chance you had at the start is still sitting there. But the 2 in 3 chance that the car was in the other two doors, when the host opens one of them and shows you it's empty, that entire 2 in 3 chance transfers to the only other unopened door. So your door still has 1 in 3 odds, and the other door suddenly has 2 in 3. That's why switching wins twice as often as sticking. To see it clearly, imagine it in story form. You pick door A. If your first choice happens to be a goat, which happens 2 times out of 3, Monty opens another goat door and leaves the car behind the remaining one. If you switch in that case, you win. If, on the other hand, your first pick was the car, which happens only 1 time out of 3, Monty still opens a goat, but switching then makes you lose. So switching wins about 2 times out of 3, while staying put wins only 1 time out of 3. Still feels weird, right? Let's crank up the scale. Picture 1,000,000 doors. One car, 999,999 goats. You pick door A. Random shot. Your chance of picking the car is practically 0. Now the host, who knows everything, walks down the line and opens every single door except one other. And every single one of those open doors hides a goat. Suddenly, only your door and one other remain closed. Would you still trust your random first guess? Or would you switch to the one door the host deliberately didn't touch? Of course you'd switch. The logic is exactly the same when it's only 3 doors. It's just harder to see because the numbers are smaller. The magic of this problem, you see, it really depends on a few quiet rules. The car's position? Well, it's completely random. The host, though, he knows exactly where it is. He always opens a door with a goat behind it. And, he always gives you the chance to switch. Now, if any of those rules change, let's say if the host picks a door at random and might accidentally show the car, well, the math changes too. But, under the classic game show setup, switching is always the better move. Think about it this way. Your first choice is pure guesswork. The host's reveal isn't. It's based on inside information. Whenever someone who knows the answer removes a wrong option for you, the odds shift toward whatever they left behind. So, switching is basically you saying, I trust the new information more than my random first guess. If you still don't believe it, you can test it yourself. Take 3 sticky notes, write car on one, and goat on the other 2. Shuffle them, pick one, then, pretending to be the host, Reveal a goat from the remaining two and decide whether to switch or stay. Do it 30 times. Keep score. 1 column for stay, 1 for switch. The switch column will dominate. You'll feel it, not just see it. People fall into the same traps over and over. They think 2 doors left means 50-50, but that ignores the host's knowledge. They think their first pick had meaning, but it didn't. It was random. They feel like switching is cheating, or like it's betraying their instinct, but the game rewards logic, not pride. In the end, the Monty Hall problem is a lesson in how information changes probability. It teaches us that what seems like a fair 50-50 choice is actually a 1 in 3 versus 2 in 3 split, disguised by clever presentation. So next time you find yourself on a game show, and the host opens a door to show you a goat, don't hesitate. Smile, thank them for revealing some truth, and confidently say, "I'll switch." Because behind that other door, statistically speaking, that's where the car is waiting.